Hey guys, welcome to this final hand-in for COMP409 Project 3. You can see it's 9:55 on Friday, so I've got to kind of hurry up and get this all finished and submitted, but this is the final thing, so yeah, pretty happy. I thought I'd give you a bit of a run through, maybe a quick look at the code and sort of an idea of how you would use this from a user's perspective. So here we've got some models split up into these model grid pieces. The models were sourced from Video Copilot. They've got a futuristic city pack, which is free to use, so that's pretty cool. Downloaded that. I split them up by myself and colored them by myself. Basically, the idea was that you wanted to chuck them into these one by one little pieces, which is used by my node, which you can see here. Cool. This is the unit labeler node. Basically, you'd give it these two meshes, or as many meshes as you like, and we can see the results of this algorithm, what it does upon it, in these images here, which have been rendered using PBRT. So you can see it generates a big city. We've got different shots here. You can also see that it's copying different, features of the model. It's recognized the patterns and what goes next to what, and extends different parts to create different sort of buildings from one input building, if you'd like. Yeah, so the algorithm sort of analyzes the topology and then replicates it en masse. And you can see in some of the other images here. So that's pretty cool. I thought we'd just jump across to the code first, have a bit of a look at that, and then we'll take a run through. So if we jump across to the code, we've got three main modules here, or actually four. We'll bring up that one as well. So this is my unit labeler node class. It's pretty big. It's got all of the higher level functions operating under the class procedural unit labeler. It's also got an associated manipulator down here, which we use for allowing the user better interaction with the system. So it's pretty cool. We've got the Discrete Model Synthesis class, which is used Paul Merrell's. This is the dude who came up with it first, and this is my implementation here. So this is somewhat of a not as big file, but still pretty grunty, and is responsible for all of the generation. The unit labeler exporter class is responsible for the rendering. Well, this and the PBRT exporter file, which I'll get to in a second. Basically, this adds all of the procedurally generated content to the PBRT file, and then tells PBRT to render it. And the voxel grid class is really just a utility class for basically managing what I'm doing. Yeah, it's got a bunch of math for interfacing with a voxel grid. Now the PBRT exporter is actually one that I've sourced from online. We've used it in COMP408. This dude has basically made this class, and it's pretty awesome. But as you can see from online, it's got all these extra sort of things to it, and all I really need it for is to export geometry and geometry materials and so on and so forth. This is quite a complicated task, which wasn't really required for this assignment. So I've used this third-party software, but I had to modify it heavily to make it work with my system. So basically the way it works is that this export module will initially export the scene, export these guys, and then what my unit labeler exporter class does is takes that exported PBRT file, goes through, recognizes the model and the composition of each of these. Oh, excuse me, that's just an alarm. And then we'll go through and write this out en masse according to whatever we generate in our node. So yeah, it's pretty heavy, and it comes out with a pretty big file, but it's sort of, yeah, it's using this to our advantage and then expanding upon it here. Great. So let's go through and have a look at our node and how we would play around with this. So you may remember from the second video, basically the idea was to assign meshes to the node simply by clicking on the mesh, then clicking on the node, and then hitting Associate Model. What that does is if this is the first one that we've clicked on and the first one we've associated, it assigns that mesh to label 1. So we go through and assign all the others. Now I've already done this. So I've got 7, 1, 2, 3, 4 here. And you'll see that if I click on the node, 1, 2, 3, 4 are the labels which are corresponding to this column here. Now you see that I've done a 2 above a 2 and a 3 above a 3. The reason for this is basically that it allows our algorithm to extend these features and place them up atop one another if it wants to. It gives it that option, which is why we get variable heights in some of the buildings. You can see for this model here, which is represented by this green column, basically we've got the same sort of thing going on. This is the same 2 labels here, and so it basically tells the algorithm that this piece in the middle can be stacked upon itself multiple times to achieve different heights. Cool. So this is our input grid, and we've laid it out like so, effectively defining what pieces can sit adjacent to one another. When we hit generate, it takes about 2 minutes to generate a 20 by 20 by 20 grid. It will generate an output model. Now I've already done this, so I'll just flick my display from my input to my output, and boom, you can see this is sort of what it generated for us. And you can see that, basically what we had in the input model is preserved in the output. So this piece was always on the top in the input, and similarly it's always on the top in the output, for example. Now an extra feature I've put in for this I guess version is the constrained ground feature, and what that basically does is leaves a row at the bottom of blank space. This is necessary to basically ensure that if a piece is on the ground here, it will remain on the ground here, and if a piece is above the ground here, it won't fall to the ground in the generated output. So for realistic models, you would typically want this on. There may be some cases where you don't, and so you can flick it on and off. So it's pretty cool. So what we can do is we can now flip around. This is my proxy, so just cubes representing model pieces. We need to make sure we're also in the legacy default viewport renderer, just in case you'd forgotten, just so the web OpenGL will work. So that's cool. So we might get to a position that we like, something like this. Position the camera like so. Okay, bit of tilt there. And then all we do, so we can bring up our output directory. Sorry. So I've found a directory here, outputs, and then we can link up our PBRT directory there, which is great. Give our file a name, final4, and we just click render. And as you can see down on the log here, basically it goes through and exports the meshes that we've got in our scene. So at the moment they're the 2 source meshes that we're putting in. And then once it's done that and found it, it will render it so we can see the render's complete, and then it pops it out open in fcheck, so we can check what it looks like here. Now as you can see, no actual mesh was added to Maya during that export process. It was all done through text in the background, through PBRT. But this file, this image, has now been put out to users Robbie desktop outputs. So if we go there and we go desktop, outputs, and we can check renders, we can see final 4 and corresponding there. Great, so that's pretty much how this guy works. As part of the hand-in file, I will attach a README that will list any technical specs you need to get this thing up and running. But yeah, I mean, I think overall, I'm really happy to have done this. It's quite a powerful tool in that you can give it any sort of model and any sort of connectivity information, and then it can build up the system for you I've kind of kept it at 100 by 100 by 100, so that's as big as you could go, 1,000,000 voxels. But you can achieve pretty massive and impressive sort of things like a city through a tool like this. Great, thanks for listening. Enjoy.